Oh, I wrote it down wrong. That's my bad.
It's okay. I need to check also. I have to be sure. Okay. Right. Don't worry. Okay. If I make a mistake, you get fine. If you just want to verify, it's also okay. Okay. All right. So the next thing is we are going to find. The question asks us to find. Okay. The question asks us to find the neutral axis intersecting ABD. Okay. That's what the question asks. So for that case, okay, I'll still need to find point B. Why I still need to find point B is so far everything seems to be in tension, right? I don't know whether is there any if everything is in tension, there's no intersection at all. Okay, so we're going to find stress X at point B again. Okay, so we know that Px over A is in tension, right? So we have My over Iyy multiplied by Z, Mz over Izz multiplied by Y. Okay, so by looking at our moment vector, so this is where our point B is. So this is minus, right? And point B about Mz is also minus. Okay, so this will be equal to 125 minus 166.67. And now we have a minus 250. So this will be equal to 125, 66.67 minus 250. So this is equal to minus 291.67 PSI. Okay. Now there's a way to find the position of the neutral axis by using the formula, but I don't like to just plug in the formula. You can by using, what do I mean by analyzing the formula? Okay, so if you use, okay, so we're trying to find the position of the neutral axis. Okay, so neutral axis, we know that stress X is equal to 0. So you can apply the formula where you have stress X is equal to Px over A minus plus by My over Iyy multiplied by Z minus by Mz over Izz multiplied by Y. Okay, you can use the formula, but I don't want to use the formula. I want to use high school math. Okay, simple way of doing stuff. Okay, simple way always win. Okay, if I teach you, we're going to use the formula, okay, it's also it's easy also. Don't get me wrong, it's very easy, but you cannot visualize what is going on. Okay, you just treat it like a black box and there you go. Okay, I want you to be able to visualize. Okay, visualization is very, very important in this topic. Okay, so now we are going to find the so we know. Okay, let me draw up the stress view for you, or rather, let me write up the stress view for you. So we already found out that this is point A, this is point B, and this is point D. And we already found out that this is minus 291.667 psi. Yeah, I think I'm missing another 6 down here. Okay, and then we have positive at point D, 208.833 psi, and then we have a positive 41.667 psi. Okay, so we know that at a certain point out here, right? At a certain point out here, this is just a sketch, okay? A certain point out here, stress X is equal to 0. And then we also know that it will be a certain point out here, okay? Stress X is equal to 0. So what we are trying to do regarding the neutral axis is we're going to identify a line, Okay, we are going to identify a line. Okay, so the line will start from here and we'll go up to there. Okay, and on this line, right, on this line is where we get our stress X is equal to 0. Okay, anything above or anything on one side, okay, of the structure, everything will be under compression. Anything at this end, okay, will be in tensile. It just make me think about the line where you have communists at the top, okay, Republican on the bottom, okay. North and South Korea, right? So let's just use simple math for crying out loud, okay? Don't do anything complicated. Okay, so I'm going to show you now the simple way of doing it. Okay, so we just draw a line. Okay, so this line represent point A. Over here represent point B. And at point A, you know that our stresses are in tensile. Okay, so this is 41.667. And then at the other end is dealing with 291,667. Okay, so 1, 2, 3. Okay, so this is your minus 291.667. Okay, so you just join the two lines together at the ends. This is just a sketch, by the way. Okay, so this is a distance x, right? And then the distance from here to here will be 4 minus x. Okay, so they all share the same gradient, right? So we know the change in y over the change in x. Okay, so you can form one equation. So it's 41.667. That's a change in y over x. And this thing will be equal to minus 291.667. Okay, and then at the bottom, okay, is 4 minus x. Okay, so I mean you can write, yeah, you can just use this equation over here, or you can form any gradient equation. Okay, so this is one of it. So 4 minus x, so this is x multiplied by minus 291.667 divided by 41.667. Okay, so 291.667 divided by 41.667 is equal to 291.667 divided by 41.667 is equal to minus 7. Okay, so 4 minus x is equal to minus 7x. Okay, so 4 is equal to minus 6x. Wait, why am I getting a minus down here? You know what? I'm going to form a different equation. Sorry. So I'm going to take the entire height. I'm going to take this as 4. Okay. So if I take an entire height, the change, I don't think I should include the minus sign down here. I think that was my bad. Okay. Because it's the change that we're looking at. So plus by 291.667 is a change in height. Okay, I think I should have ignored, and I think it's more straightforward. So I'm taking this entire distance from here to be 4. Okay. And I just want to find x. That's why I add the change in y. Okay. So this is easier because you don't need to cross multiply. Okay. So 4 times by 4, 41.667 is equal to 166.668. And this is equal to 41.667 plus 291.667 is equal to 333.334 x. So x is equal to 166.668 divided by 333.334 is equal to 0.5. 0.5 inch is from A. Okay, from point A. I think just now I need to put it as positive and not negative. The answer will be the same. And then the last one, okay, the last one. Time flies when we are teaching. I don't know about you. On my side, time just disappear. Okay, so we have a point down here. So again, this is our point B. Same thing, okay. This is our point B. And this is our point D. So minus 291.667 and 208.833. Okay. So we have our stress now. So this is our 291. Minus, and then our plus 208. And then we construct a line. Okay. And I'm going to relative from point D. This is x. This whole distance from here to here is 1.8. Okay. So again, the same delta y over delta x. Okay. So if it's x, so our delta y, I know our delta y is x. I know it's confusing. Okay. So this is 208.833. And this will be equal to 1.8 over the change in x is 208.833 plus by 291.667. Okay. So we have our we cross multiply, or we just calculate our x is equal to 1.8 times by 208.833 divided by 208.833 plus by 291.667 close bracket is equal to 0.751. And this is from D. Okay. So the distance from, so I'm just going to briefly sketch this out. So if this is our so this is our point A, point B, point D, right? So 0.75, sorry, the first one is 0.5. So this is our 2, 1. So this is our first point of intersection over there, right? So this, the height is 1.8, 0.9. So it's somewhere around here, right? So this is our neutral axis. As mentioned, this side, anything this side will be on compression. anything on the other side will be tensor. Okay, so I am not able to do shearing stress. We will carry on shearing stress, a new topic on Friday. Okay, and show up. Okay, because shearing stress is not a straightforward topic. Okay, it's quite complex. In fact, it's the most complex class that lecture that we will have. Okay, going from 3 hours to 1 hour class will do that to you. So. Okay, I'll see you guys on Friday, and I will extend the quiz date. Okay, anyone have questions, stay behind. I'll still be around. Okay, and I'll stop recording first.